Part 1. Intro. Narration. Imagine waking up one day and looking into the night sky. There are no stars, no galaxies, no glowing Milky Way stretching across the darkness. Just endless blackness. It may sound like science fiction, but according to modern cosmology, this is exactly how the universe could end. Everything we know, every star, every planet, every galaxy, and even time itself may eventually disappear forever. The universe has existed for nearly 13.8 billion years, but compared to its possible future, that is only the beginning. Scientists believe our cosmos is slowly moving toward a final destiny. But what will that destiny be? Will everything simply freeze? Will the universe tear itself apart? Or could it collapse back into another Big Bang? The answer depends on one of the greatest mysteries in physics, the ultimate fate of space itself. Today, we'll travel billions, trillions, and even unimaginable numbers of years into the future to witness the death of everything. By the end of this video, you'll understand why the end of the universe is far stranger than most people ever imagined. Part 2. The universe is already dying right now. The universe may look alive. Stars are shining. Galaxies continue forming new solar systems. Black holes consume enormous amounts of matter, but appearances can be deceiving. In reality, the universe has already begun a process that cannot be reversed. The first clue came nearly 100 years ago. Astronomer Edwin Hubble discovered that distant galaxies are moving away from us. The farther away they are, the faster they seem to recede. This revealed something astonishing. Space itself is expanding. Imagine drawing dots on a balloon. As the balloon inflates, every dot moves farther away from every other dot. The galaxies aren't flying through space. Instead, space itself is stretching. For decades, scientists assumed gravity would eventually slow this expansion. Perhaps the universe would stop growing. Maybe it would even collapse. But in 1998, astronomers discovered something shocking. The expansion isn't slowing down, it's accelerating. Some mysterious force, called dark energy, appears to be pushing galaxies apart faster and faster every second. And nobody truly knows what dark energy actually is. This invisible force now dominates nearly 70% of the entire universe. If it continues forever, the future becomes unimaginably bleak. Part 3. The Death of the Stars. Narration. For now, the night sky appears eternal. Every evening, billions of stars light up the darkness, but stars are not immortal. Each one is powered by a finite supply of hydrogen deep within its core. As nuclear fusion slowly consumes that fuel, every star begins a countdown toward its own end. Massive stars burn brightly, but they also burn fast. Many live only a few million years before exploding in spectacular supernovae, scattering the elements that one day become new stars, planets, and even life itself. Smaller stars, like our sun, are far more patient. The sun has already lived for about 4.6 billion years, and it still has roughly 5 billion years of fuel remaining. But eventually, even our star will change. It will expand into a giant red star, swallowing Mercury and Venus. Earth may survive the expansion, or it may be consumed entirely. Either way, our planet will become completely uninhabitable long before the sun reaches its final stage. When its fuel is exhausted, the sun will shed its outer layers into space, leaving behind a glowing white dwarf. Across the universe, the same story will repeat trillions upon trillions of times. One by one, the stars will disappear. Eventually, no new stars will be born. The galaxies that once blazed with light will slowly fade into darkness. The universe will enter an age unlike anything we can imagine, an era where light itself becomes incredibly rare. And yet, this is only the beginning of the end. Part 4. The Age of Black Holes. Narration. After the last stars fade away, the universe will enter a new and haunting era. There will be no sunrise, no starlight, no glowing galaxies filling the darkness, only cold remnants of dead stars, lonely planets drifting through space, and the most powerful objects ever created, black holes. For an unimaginable length of time, black holes will dominate the universe. They will slowly consume anything that comes too close, dead stars, planets, even other black holes. As galaxies continue to drift farther apart, these cosmic giants will become increasingly isolated, floating through an ocean of almost perfect darkness. It may seem as though black holes could survive forever. For decades, scientists believed exactly that. But in 1974, physicist Stephen Hawking made a discovery that completely changed our understanding of the universe. According to quantum physics, black holes are not truly black. They slowly leak tiny amounts of energy through a process now known as Hawking radiation. The larger the black hole, the slower it evaporates. A supermassive black hole could survive for an almost unimaginable amount of time, far longer than all the stars that ever existed. But even those giants cannot escape the laws of physics, trillions upon trillions of years into the future. The last black hole will finally disappear, and when that happens, the universe will become quieter than ever before. Part 5. The Final Darkness. Narration. After the last black hole disappears, the universe enters its final chapter. No stars, no planets, no galaxies, not even black holes remain, only an unimaginably vast, almost empty expanse of space. The remaining particles drift farther and farther apart as the universe continues to expand. Over unimaginable span of time, even the smallest traces of energy become thinner and colder. Eventually, almost nothing happens anywhere. No explosions, no light, no new beginnings. This possible future is known as the heat death of the universe. It doesn't end with one dramatic explosion. Instead, it fades away so slowly that time itself seems to lose its meaning. But scientists have proposed other possibilities as well. If dark energy becomes stronger over time, the expansion of space could accelerate until galaxies, stars, planets, atoms, and even the fabric of space itself are torn apart. This terrifying scenario is called the Big Rip. Another possibility is the opposite. If gravity somehow overcomes expansion, the universe could stop growing and begin collapsing inward. Galaxies would rush toward each other. Temperatures would rise. Everything would fall back into an unimaginably dense state known as the Big Crunch. Some physicists even wonder if that collapse could trigger another Big Bang and the birth of a completely new universe. The truth is, no one knows which future awaits us. Outro. The last question. Narration. The fate of the universe may seem impossibly far away. Long after our sun is gone, long after the Milky Way has disappeared, and long after the last black hole has faded into nothingness, the universe may finally fall silent. But perhaps the most fascinating part of this story is that we still don't know how it truly ends. Every new telescope, every space mission, and every scientific discovery brings us one step closer to understanding our place in the cosmos. The universe continues to surprise us, and that means the greatest discovery may still be waiting. If you enjoyed exploring one of the biggest mysteries in science, make sure to subscribe to Cosmic Truths for more journeys through space, time, and the unknown. Because the more we learn about the universe, the more mysterious it becomes. Thanks for watching, and I'll see you in the next cosmic adventure.